To Unit 4 with momentum, and we are finally up to date with the units, so hopefully this will be of much more use than like all the stuff we uploaded for last semester like very recently, since well it's really good for like reviewing stuff and all that, but now we're gonna be keeping up to date with what Mr. Silva is teaching, hopefully. Alright, so let's begin with momentum. So conceptually, momentum is the resistance of an object to stop moving. So it's very similar to inertia, which we learned in Unit 2, I believe, with Newton's first law. And inertia is the resistance to change of motion. So, like, you always hear people say, like, if an object has a lot of momentum, then it's, like, harder to stop. And momentum depends on two factors, which are mass and velocity. So think about it this way. If an object has a really high mass, let's say that there's a truck rolling down a hill, it's going to be pretty hard to stop that truck because it has a lot of mass. While if we replace that truck with like a toy car, for say, that toy car does not have a lot of mass, so it's going to be stopped pretty easily. And then it's the same thing with velocity. So if you shoot a bullet while it's moving at a really high speed, then it's going to be hard to stop that bullet. While if you just like throw a ball or something, then it's not moving at a high speed, even though its like mass is going to be greater than the bullet, but it's easier to stop. So yeah, that's momentum in a conceptual way. And then the way we calculate it is P equals mv. So P is the symbol for momentum, and then m is mass, and v is velocity. So mass times velocity. Units are going to be kilograms times meters over seconds, or basically newtons over seconds. And the important thing to note about momentum is that it's a vector quantity, so it has magnitude and direction, and please note, I do not want to give you feedback. And it's also a conserved quantity, which will come into play later. So we have things like conservation of mass, conservation of energy, and we also have conservation of momentum, which we will be going over later, as I said. And I think that's about it for momentum. Yeah. Bye.